Hey y'all, so I'm going to represent Boyle's law with this syringe and this stopper. So what I'm going to do first is I'm going to fill it up with about 10 cc's of air, and that's just a volume for this particular syringe. That's just the unit of volume. So then I put the stopper on top. What this does is it causes no air to be able to escape or come into the syringe. Now, Boyle studied the relationship between volume and pressure. So this is at a constant temperature, which means that the temperature does not change. So what I'm going to do is I'm going to increase the volume that this gas has to move around. And right now, because there's open airflow in here, it's the same pressure as the atmospheric pressure around us. But when I put a stopper on it, now the pressure can change. If I increase the amount of space that this gas has to move, there's a decrease in pressure in the gas because it's more spread out, it has more room to move, and therefore it hits the walls of the container less often. Now, if you take a look, when I let go of the plunger, the outside pressure, because it was higher at that point, ended up pushing the plunger back in. So I'll do it one more time. So right now, inside the syringe, when I increase the amount of space that the gas has to move, has a lower pressure. And when I release the plunger goes back in. Now, on the other side of that, if we start with more air, now we have lots of air in here, and I'm going to decrease the amount of space that the gas has to move. The pressure is increasing. So with this decreased volume, because the gas has less space to move around, there's a high pressure in here right now. It's so high that I can't even push the plunger in anymore. And I know it's so high because when I let go of the plunger, that high pressure, the gas particles that were hitting the walls of the container pushed that plunger back out.